All right. Find a point on the parabola that is closest to the point 1, 4. So kind of think about, so first of all, First of all, this parabola, which direction does it open? Everybody has to, you can't wait for someone to figure this out for you. That way. Yes, to the right. So basically this parabola looks like this, and then 1, 4 is maybe somewhere here. We're eventually going to draw a better one. The question is which point on this parabola is going to give you the shortest distance? Plug what in? Into what? How do you even find the distance? Why? That's sense. I don't know. I'm just trying. Yes, distance formula. We want to figure out the distance.
Take the derivative. It's
right.
the minimum distance.
Good. All right. So we have a parabola that's y squared equals 2x. And then we have a point that's 1, 4. We want to find the shortest distance to the parabola. Shortest distance to the parabola. That means we want the distance to be the smallest. That means we need a formula for distance. Therefore, distance formula. And we want the minimum distance. Therefore, like Zach said, derivative. Okay? Man. Okay.
What's the distance formula? I don't remember.
Well, okay. All right, so I'm going to leave you guys with the distance formula. You and your partner needs to try something to solve this. Okay, distance formula is square root of x2 minus x1 squared plus y2 minus y1 squared.
I've almost got the derivative.
Oh, okay. Well, let me show you a fast way to get to the derivative. Okay, so let's say this is 1, this is 2, right?
Yeah.
Okay, so then 1 is fixed point, 1, 4. 2, you probably want to make it a little bit easier for yourself, right? So x is equal to y squared over 2, right? All right, so d is x2, I'm sorry, x minus 1, right? I'm plugging x in. No. What am I doing?
Yeah, it's y squared over 2.
Yeah, y squared over 2 minus 1 squared plus, why am I getting stuck? Okay, y minus 4 over 2. All right, now take the derivative, which is crazy. So here is the trick. Yes, it's a chain rule, but that's crazy. The trick is just square both sides because the square of the distance is still going to be the shortest. Right? So then d squared is equal to y squared over 2 minus 1 squared plus y minus 4 squared. Now, when you take the derivative, you're not doing a chain rule. You just want to find the shortest d squared. Does that make sense? You're not doing a 2d times d prime. That's not what you're doing. You just want the shortest d squared. The distance squared, which, are you okay? D squared is still, a short distance squared is still short. The distance between here and here, and distance between here and here, if I square it, this one, if it's short, it's still going to be short.
Got it.
Yeah.
Okay, so you're going to take the derivative of d squared over dy. All right, and you want to find the shortest y. The answer is 2 on the parabola.
I got it!
We are going to have to go back to this problem. This is very hard. Okay, this is very interesting, but very hard. You have to think a lot. I had to think a lot when I was doing it. All right, let's look at this question. A man launches a boat from point A on the bank of a straight river, 3 kilometers wide, and wants to reach point B, 8 kilometers downstream on the opposite bank, as quickly as possible. He could row the boat directly across to point C and then run to B. Or he could row directly to B, or he could row to some point D between C and B and then run to B. If he can row 6 kilometers per hour and run 8 kilometers per hour, where should he land to reach B as soon as possible? We assume the speed of water is negligible compared to the speed at which the man rose. This is crazy.
Okay, you just have a motor though.
Still, we want to figure out what's the fastest way to get there.
Okay, definitely doesn't want to go to point C.
He definitely does not want to go to point C. That's correct.
Want to go straight to point B either.
Yeah,
So
point D.
so deep.
Boom! We're already done with the problem.
Where is the optimum?
It could be any point. Not
Yeah, exactly. So that's why we need to try to solve this. Okay, he's either gonna roll directly here and run, or he's gonna roll, which is both are not optimal. Obviously, it's gonna be D. The problem is where.
I bet it's
Where exactly does this have to be so that he can run and?
I bet it's
like
4
get out of the boat.
We're gonna say that's negligible as well. All right. Yes.
Why would it not be C if he runs faster than he rose?
He runs faster than he rose. It could be. It could be. Either. Actually, I don't remember what the answer is. So we need to solve this problem. Either way, if we try to set up the problem, it will tell us how to, what is the optimal. What
Try to minimize.
we're trying to get there as fast as possible.
So
Not
time.
minimize time. Correct.
maximize speed.
All right. So we have three kind of things going on. We have time, we have speed, and we have distance, right? Those three things make this equation. Distance equals rate times time, right? So we don't really care about how long the distance is. We want the time to be minimum. So eventually we want to find time. Time is going to be distance over r. So distance over the rate. Okay. All right, so let's think of a very universal way to map out our distance. So no matter what he does, he will have to roll first, right? And then he will have to run.
Yeah.
Okay, so we need to figure out how to talk about this distance. Let's call it z. Okay, so it's always, or I don't know how to say it. It's always going to be z plus the leftover here, right? What's the leftover? 8 minus x. So it's always going to be z plus 8 minus x. The problem is, what is z?
No.
Yes, it's the hypotenuse of what?
The right triangle.
The right triangle. 3 and x. So z squared is equal to 3 squared plus x squared. All right. Yes?
Oh, never mind.
Okay, so that's that. And the total distance, no matter how he runs, the generalized way of thinking about it is the diagonal, the hypotenuse, plus this leftover part, which is going to be square root 9 plus x squared plus 8 minus x. Okay, that's the distance. Now, this is not the correct distance in terms of time, right? This part he's going to row. This part he's going to run. So remember, we're trying to minimize time. We're not trying to minimize distance. So how do we find the time he rows? Not times 6, divided by 6. Remember, time is distance divided by rate. Okay, so we want the total time. The total time has to be minimum. So the rowing amount of time he's rowing is this distance that he is rowing divided by how long the rate he can row. So 6. The amount of time he's going to run is 8 minus x, that's the distance, divided by the time he is, the rate he's running, which is 8. Okay, we want that to be minimum.
Derivative.
Yes. think this should be right. Double checking, yeah. All right, I'm just gonna give you the answer. 9 over square root 7. Okay, so this question says find the largest or area of the largest rectangle that can be inscribed in a semicircle of radius r. This is a very, very typical problem. So what you want to do is draw a picture first. So you want to draw a, semicircle, and you have a rectangle that's inside. So it doesn't really matter how you draw this rectangle. You just need to draw it. The key things on the circle is the center. And it tells you that it has a radius r. So let's label that. Okay, so we are trying to find the largest area possible of this rectangle. So we do need an area. That means we need to have some dimensions of this rectangle. So let's say we make this x and we make this y. Kind of x corresponds to the x-axis and then y is the y-axis. So then this area that we're trying to find is going to be xy. And we want xy to be the largest possible, so eventually we need to take derivative and then find a maximum. However, xy has to do with the radius r because it's stuck inside the circle. So we have to somehow relate x, y, and r together in one equation. It's a little bit tricky. So the trick is to see that from the center to the corner of this rectangle is what?
R.
Yes, correct. Then actually this makes a right triangle.
Oh.
So then what is the length on the bottom? Half x, yeah, x over 2. So since it creates a right triangle, we can use the Pythagorean theorem. So x over 2 squared plus y squared is equal to r squared. Okay, so x over 2 squared plus y squared is equal to r squared. Okay, so you need to remember that r is a constant because it is a fixed circle. It's not getting bigger, it's not getting smaller, it's just a number. So I can actually change r to 5 or 6, whatever number I want, but it's going to be a constant. So we are trying to find the largest area, which is the largest x times y. Again, we cannot find the derivative if there are two variables at the same time. So we need to write x in terms of y or y in terms of x. So which one do you guys prefer? Y in terms of x. Okay, so we're going to solve this. So y squared is equal to r squared minus x over 2 squared. All right, y is equal to square root of r squared minus x over 2 squared. Huh? Okay, now we're going to plug that in or substitute it into y. So this is x times square root of r squared minus x over 2 squared. All right, we want that to be the maximum, which tells us we are going to take derivative. Yes, this is going to be a derivative with product rule with a chain rule inside. Is it in terms of y better?
No.
No, I think
No.
it's about the same. One has a fraction, one doesn't have a fraction, but you still have product rule with the chain rule. All right, go ahead and take the derivative. All right, I'm going to try to help you guys. All right, so x times 1/2 r squared minus, I'm going to multiply out the x over 2 squared into x squared over 4. So x squared over 4 to the negative 1/2 times x over 2. I'm just taking that derivative of the chain rule. Okay? X, the minus. Okay, x times the derivative, so chain rule, 1/2 times this to the negative 1/2 times the derivative of this, which is negative 2 over 4 x So negative x over 2.
It's x over 2, right? It's x squared.
Yeah.
It's x over 2 squared.
X over 2 squared. She distributed she squared everything. Inside.
Oh, yes.
But then why is there still squared?
Why is this? No, you take 1/2 times whatever is inside.
Is that a negative?
This part?
Yeah, is that
Yes, that's a negative.
I got this so wrong.
Wait, what?
What's
Four.
that? Why is it not just negative?
Oh, I see now.
Okay, this part, let me just rewrite it. X square root r squared minus x squared over 4.
Oh, you have to.
Okay, plus square root of x squared, I'm sorry,
Oh, I didn't product rule.
r squared minus x squared over 4. That's it. Times the derivative of x is 1. Okay, now try to simplify this. So negative x squared over 4 square root r squared minus x squared over 4 plus square root r squared minus x squared over 4.
Wait,
Yes.
okay, why is the derivative of x over 2 squared not just negative x?
What? The derivative of this thing?
No, the other one.
Well, that is the same.
What?
It's the same thing?
Yeah. If you just distributed the square, the top, and then the numerator. And the
Okay, so you guys figure it out. I'm gonna continue. So we're gonna multiply both sides by the denominator so we can simplify it. I'm gonna just do it in my head. Okay, I'm assuming you guys can do this. So multiply this on this side. Okay? All right. Negative x plus 4 times r squared minus x squared over 4 all over 4 square root r squared minus x squared over 4.
Negative x squared.
Did I write something wrong?
Yeah.
First.
Oh, yeah. Okay. Okay, now simplify. Negative x squared plus 4r squared minus x squared all over 4 square root r squared minus x squared over 4. That is negative 2x squared plus 4r squared all over 4 square root r squared minus x squared over 4. All right. Now we do what?
Equal to 0.
Make it equal to 0, top and bottom, and then do your sign chart, figure out what r makes it maximum. All right, make it equal to 0. Negative 2x squared plus 4r squared is equal to 0. We're solving for x, okay? R is just a variable. 4r squared, r is just a constant, equals 2x squared. So divide by 2, 2r squared equals x squared. Square root x is equal to square root 2r. We don't take the negative because we're talking about real circles, so we don't want to go negative. In the denominator, 4 root r squared minus x squared over 4 is equal to 0. So divide by 4. R squared minus x squared over 4 equals 0. Square both sides. R squared equals x squared over, minus x squared over 4 equals 0. Add that on both sides. R squared equals x squared over 4. Multiply by 4. 4r squared equals x squared. Square root 2r equals x. Okay, sign chart. Okay, we want this, the smallest, huh? The middle one? What's middle one? Oh, okay. Let's. Okay, so the smallest number this can be is when it's 0, right? You know, we just put 0 in there. And then we have square root 2r. And then we have 2r. And that's it. Smaller than square root 2r, let's just say is r. Yes. Between square root 2 and 2, let's say square root 3. because 2 is square root 4, right? So in between square root 2 and square root 4 is square root 3. And bigger than 2r, let's say 3r. I think 3r is already more than possible in this circle, but we'll see. All right, let's put r in. Positive, right?
Yeah.
Yeah.
I just can't figure it
Okay. Put it in here. We're putting in here, right? In the denominator, this has to be positive. We can't have a negative square root, so it has to be positive. Negative 2 times square root 3r squared. Negative, yes. 3r squared.
out. No, it's
It will make the denominator imaginary, I think. Yeah, this won't even work. So this doesn't work. Okay, so positive, negative, so that has to be the maximum. All right, now let's look at the question. Find the area. Find the area that is the largest. XY. All right, we gotta do XY. Okay.
I already asked.
Y, huh? 2xy. Yeah, I didn't do it that way. Okay, x is equal to square root of
oh man.
Elizabeth.
Sorry.
Okay, square root 2, I'm sorry, it's just r squared. R squared minus square root 2r over 2 squared. R squared minus 2r over 4 squared, 2r squared. So that is r squared minus r squared over 2. That is square root of r squared over 2. All right, I don't want to simplify that. A is equal to xy, so that's square root 2r times square root r squared over 2.
Can't wait, no. Make it easier for yourself. Just put r over square root 2.
That's the
and
answer?
The answer is r squared.
Why?
Mm.
Wait, how would r squared minus r squared over 2, r squared over 2?
1/2.
1 minus 1/2 is 1/2.
Oh,
Wait, so for all of these problems like this, the answer will be r squared?
A lot of it, because you just think about like, what is the maximum way to actually have this much area within this much volume? It's usually something that's very symmetrical, not something that's
Hold up.
asymmetrical.
So the area will
So like square or circle or sphere are usually your ideal size.
So if we have a half circle and they ask like this,
Um, I don't know the actual logic behind everything, but you could probably use those and then just check them.
I guess that it's r squared.
You could check. You can guess whatever you want. Okay, let's try this next one. This one actually does not really have to do with any shapes and things like that, but it has to do with derivatives. Okay, a store has been selling 200 flat screen TV sets a week at $350 each. A market survey indicates that for each $10 decrease in price, the number of sets sold will increase by $20 a week. Find the demand function and revenue function. Oof. I think we're gonna skip this for now. Okay, that means